Today we are going to talk about proportional and non-proportional relationships. Quantities are proportional if they have a constant rate or ratio. They are non-proportional if they do not have a constant rate or ratio. Determine if the data shown in the table represents a proportional relationship. If yes, give the constant rate. So what we're doing is we're going to take our y value, so this is our x, this is y. We're going to do our y divided by our x. And if it's always the same, so 6 divided by 1, 6. 12 divided by 2, 6. 18 divided by 3, 6. And 24 divided by 4 is 6. So since those are all the same thing, we're going to say yes. And then we're going to say 6. Oh, that is not a 6. I don't know what happened there. 6. Okay. We're going to do the same thing with the next one. We're going to do 595 divided by 4. And I got 1.4875. Then we're going to do 915 divided by 8. I immediately got a different answer, so I can stop there and just put no. Okay, so I'm just dividing the y value divided by the x value. And you can make a note over here if you want. Y divided by x. Okay, so we're going to do 114 divided by 3, which I got 38. 304 divided by 8, which I got 38. 570 divided by 15, 38. And 912 divided by 24. Again, I got 38. So I'm going to say yes, and my constant is 38. Alrighty. So a proportional relationship is also referred to as direct variation. So yes, it's a different phrase, but it means the exact same thing. Proportional relationship, direct variation. When two variables vary directly, their relationship can be expressed through the following equation. Y equals kx. The equation is read as y varies directly as x. Okay. K is the ratio of y to x. That means I can do y divided by x, which is what we were doing before. And this is called the constant of variation. It can also be called the constant of proportionality, since proportional and direct variation are the same thing. So you could hear it either way. What is the constant of proportionality or the constant of variation? Those are the same. So we're going to do exactly the same thing that we did on the beginning. Determine whether it represents direct variation. So we're going to say yes or no. Give the constant if it's yes, and then write an equation. All right, so we're going to do that division again. 2 divided by 1 is 2. 4 divided by 2 is 2. 6 divided by 3 is 2. And 8 divided by 4 is 2. So we would say yes. Our k value is the number we got each time, which is 2. So then our equation is y equals 2x. Okay. On this next one, if you try to divide this in your calculator, it's going to give you an error. If you put 0 divided by 0, so we'll have to skip that one. It's what's called an indeterminate form. So we'll do 1140 divided by 3. I got 380. 2660 divided by 7, I got 380. And then 3800 divided by 10, I still got 380. So those all match, so we're going to say yes, k equals 380. And then our equation would be y equals 380x. Okay. Last one. Again, we can't do the 0 divided by 0 part, so we're going to do 110 divided by 2, which is 55. 214 divided by 4, which is 53 and a half. So we got something different. Doesn't matter if it rounds to something or not. If it's different, it is not direct variation. So we can just say no and move on. Okay. So we're going to look at some word problems here. It says the total cost of tickets varies directly with the number of tickets. Okay, so it's trying to tell you your x's and y's here. So remember your y, that's your cost of tickets, varies directly with x, the number of tickets. If 5 tickets cost $15, identify the constant of variation. Okay, so k is y divided by x. Our y value is cost. That's 15 divided by number of tickets, which is 5. So our constant of variation is 3. So it says identify the constant of variation, done, and write an equation. Y equals 3x. The number of teachers varies directly with the number of students. So this is your y, this is your x. If there is one teacher, for every 20 students, identify the constant of variation. So how many teachers? One teacher for every 20 students. Okay, that's 0.05. So that's our constant of variation. And then so our equation would be y equals 0.05x. A car wash fundraiser, the money earned varies directly with the number of cars washed. Okay, so money earned is our y, and cars washed is our x. So, okay. If 4 cars are washed, $14 is made. So money is our y, number of cars is our x. So 14 divided by 4 is 3.5. Determine how much money is made when 15 cars are washed. So I'm going to do 3.5. So y equals 3.5x. 15 cars is an x value, so I just have to do 3.5 times 15, which would be 5250. Are there other ways that you could find this number? Absolutely. Okay, this is just specifically using direct variation to find it. But there's definitely other ways that you could work that problem and still get the exact same answer. The cost of apples, so cost of apples, is directly proportional to the number of apples purchased. Number of apples. If 8 apples is $2, okay, so I'm going to start by finding my constant. 8 apples is $2. So cost goes on top, so 2 on top. Number of apples on bottom, 8. That is 0.25. Determine how many apples were purchased for the total cost to be $4.50. Okay, well my equation is y equals 0.25x. This $4.50 is a cost, which means it's a y value. So that means I have 400, not 400, I have 450 is equal to 0.25x. I'm going to divide both sides by 0.25. When I do that, I get x is equal to, and it looks like 18. Again, are there other ways that you could work that problem and get the same answer? Absolutely. I'm just specifically showing you how to do it with direct variation today. It's important to understand that direct variation equation is y equals kx. It is a special type of linear equation, y equals mx plus b, where our y-intercept is 0 and our slope is k. So we're going to graph each of these. Y equals 4x. Our y-intercept is 0, which means we're going to start at the origin. It's a little harder to graph on here. And then I'm going to go from this point, I'm going to go up 4, 1, 2, 3, 4 over 1 right here. And then I'm going to go down 4, 1, 2, 3, 4, left 1 right there. And then I'm going to draw my line. Hopefully yours is better because mine's a little rough. Okay, 2/3 x. Again, this is going to start at the origin, so start at 0, 0. And then from there, we're going to go up 2, to the right 3. And then we could also go down 2, left 3. And then draw our line. Lastly, we have y equals negative x. Again, this is going to start at the origin. And it's going to go down 1, right 1 as many times as it can. And up 1, left 1 as many times as it can. And then draw your line. Alright, so this next part is meant for you to kind of do with your group to just kind of see. So what I would suggest is maybe trying it with your group first. And then y'all can like maybe take 10 minutes or so, try it, see if you're getting the same things, and then y'all can go over it as a class. I'm just going to quickly tell you what the answers are. So pause it here, do this with your group, take 10-15 minutes to do this with your group, and then you can play it to see if y'all got the right answers. Or you can just check with each other. But I'm going to go through this pretty quickly because I'm not showing the steps on this one. I'm just going through what you should get. So number 1, you should have yes. And it says give the table, determine whether it's direct variation. If yes, identify the constant of variation and write the equation. So yes, this one is k equals 4, which would be y equals 4x. You should have all 3 of those things. All right. Number 2 is no. So since it's no, I shouldn't have anything else written with it. Number 3 is yes. K equals negative 2. So y equals negative 2x. Number 4 is yes. That's not a yes, but that's okay. Yes. K equals 1/3. Write it as a fraction, not as a decimal. Because 1/3 is a repeating fraction, we want to write it as a repeating decimal. We want to write it as a fraction. So then our equation is y equals 1/3 x. Number 5 is no. Number 6 is yes. Our constant is 2/3. So we'd say y equals 2/3 x. Hopefully you got those right. Okay, so we're going to keep going. This time we're going to look at equations. Remember, in order for it to be direct variation, it has to be able to be written in the form y equals kx. Okay, so that's what we're looking for. So is 7, it says determine, if yes, identify the constant variation. Is number 7 direct variation? No, because it says 3x plus 1. Number 8, we would say yes, and k is that 1/2. Number 9, we would say yes, and k is negative 1. Number 10, we would say no. It's got a plus 2 on there. Number 11, we would say no. It doesn't have a number times x. Okay. And then number 12. Number 12, we would have to rewrite this. So we did some rewriting before so we could put stuff in the correct order. So I'm going to subtract this 4x first. So that gives me 3y is equal to negative 4x. And then I'm going to divide everything by 3. So this gives me y equals negative 4/3 x. Now that it's in the correct form, it's in the y equals form, I can say yes, and that my constant of variation is negative 4/3. Okay. On these graphs, what we're looking for is we're looking for that it goes through the origin, which is that center part. If it doesn't go through the origin, we can automatically say no. So if I'm looking at these, just quickly glancing, doesn't go through the origin, so I can say no. Doesn't go through the origin, so I can say no. All right, this one does go through the origin, so then I can say yes. And then I'm looking for my slope, how far up and over. This one goes up 4/2. All right, so 4 divided by 2 is 2. Okay, and then on number 16, I'm going to have to scroll down just a little bit. On number 16, it does go through the origin and it's a straight line. So then I'm going to look at the slope here. And that goes 1, 2, 3, 4, 5. It goes down 5/2. I didn't need to say yes, sorry. And that does not simplify, so I would leave it as negative 5/2. And that's that. So you will have an assignment over direct variation. So you'll have hopefully sometime today maybe and sometime tomorrow to work on that. And then for the rest of this week you'll have a review. So you'll have 2 days to work on your review and then you'll have a test. So I hope you'll have a good week. Let me know if you need anything.